up or let me know.
Yes. When
Hopefully
Matt
you
comes
guys jump
on,
for that, because that's a great opportunity.
Thank you too, Matt, for helping me out yesterday.
Oh, sure, of course.
I don't know if you're ready for class because I have 2 questions.
Yeah, I love questions. Questions are great.
Okay. So it was on the homework. I got a half a point on it asking about a survey asked how many children people have. The survey results are given on the histogram. List the raw data and commas in between them. And I did that and it only gave me half a point, and I tried putting it in brackets and then I think it gave me actually less than half a point. So I'm not sure what I'm missing on the answer, because
What problem is that? What that's
that would be
2-2.
problem 5.
Number 5.
on 2-2.
Yes.
So look like that, right?
Yeah.
So how many children people have, survey results are given in the histogram. List the raw data with commas in between those spaces. Okay, so you've got here a 4, a 1, a 3, a 2. Okay, so let's look at this histogram. This 5, for example, has a lot. That 5 is one of our frequency values, right?
Yeah.
So that 5 means that one of our values is coming up 5 times. It doesn't say 5 is one of our values.
Okay.
So for example, this column here, this one, this is a data point of 1. So in context, this means survey of how many children people have. This is the instance of having 1 child. How many people had 1 child?
4.
So there are
1, 2, 3.
4 ones. How many people had 2 children?
3.
Fair?
Right.
How many people had 3 children?
5.
So how many 3s would I have?
5 3s.
Exactly. And how many had 4 children?
2.
So that would have been your raw data. You would have asked how many kids you got, how many kids, and somebody would have said 1, somebody would have said 3, somebody 2, somebody, why did I put 2s over here? Sorry. That messed you up, didn't it? 2 people said 4. So these were the raw responses. Fair?
Yeah, that is not how I did that.
Well, and that's one of the things that we were talking about yesterday. If we put this in a, one of the things to be careful of that we talked about yesterday, if we put this in a frequency table, we'd have had 1 4 times, 2 3 times, 3 5 times, and 4 twice. And we talked about being careful about, which of these are our data and which of those are frequency. These values, the 4, 3, 5, and 2, those aren't values coming in our data. Those just tell us how often the values come up in our data. But when you're looking at just a big pile of numbers, that can be kind of hard to pick out. Fair?
Yeah.
There, saved them.
I wrote it down like a plot, like 4 1.
Right, looking at, like you were looking at, and that's what you, probably what you meant when you were doing brackets. You know,
Yeah.
you were talking about.
Yeah, I was doing it like a plot system. So,
Mm.
and then the other question that I had, if we're done with that one, is question number 13. It was, what is the maximum possible tree height for data recorded for this histogram? No, each of the class contains its lower class boundary, but not its upper class boundary. I answered the question correctly after help for the minimum,
Mhm.
and the maximum, it gives you a scale all the way up to from 55 to 95. So I would presume that the answer was 100 for maximum, but I guess maybe it would be 99.9. Is that?
Well, let me try to see what you're showing there.
I don't know if I sent you that problem.
I didn't see it. You really want to put that 100.
So it is 100.
Right. It doesn't, and that's kind of what we were talking about also yesterday with the whole 99.9. Well, where does 99.92 go? Or where does 99.97 go?
Okay.
Yeah, that 100 is a boundary, but not a value. But I'm not a big fan of that question from their perspective, because we talked about that last bin also has the extra values in it that are higher.
Yeah.
So looking at a histogram, you can't always trust what the maximum value is based on what the histogram looks like. So I'm trying to see if I can see an example of exactly how they word that question in that setting. And I'm trying to find one that has maximum on it, because that's a weirder question. I'm not seeing one on my list. It's got maximum on it.
Didn't you say 13?
Yeah, it's 2 question 13. And it jumps back and forth between maximum and minimum.
Between max and min, yeah. The ones that are coming up for me are all saying.
You have to keep getting it wrong. Trust me, I've gotten a lot of them wrong to probably go through them all.
I told you, wrong is good, right?
Yeah, I've done some searching for help, and oh boy.
The short answer is, yeah, you should be using that actual maximal value. And if that doesn't work for the maximum, let me know and I'll look at a particular instance. A couple of the questions anyway that I got sent, when I checked, the question had been a new, different question, that it switched enough that it was not representative. So
Okay.
that can be tough. Let me see if I can grab it here. If I can't, well, I'll search that out too.
Okay.
And send you something.
I know my math is really particular, but it's hard to tell when you're not confident if it's you or if it's the program.
Oh yeah. Oh, I found one. No, each collection. Yeah, I'll have to search out exactly what it wants. Ooh, I wonder if it wants that. Yep. Okay, I got an answer for you.
What's the
What it wanted was 99.
Yeah, 99.9
No.
or 99?
99. And the reason is, if you read the description, the data collected 40 randomly selected trees going at a median strip. The height of each tree in inches was recorded. Data was recorded to the nearest whole inch.
Okay.
So that sentence tells us that you don't want that 99.9. You want that 99 whole inch.
Yeah.
Fair?
Yeah. Awesome. Thank you.
Sure. and see. Somebody asked about a different number, but it disappeared from me. Where'd it go? Ah, there it is. Number 9. That wasn't the one with the kittens, was it?
No,
No, what's that one?
that one was a tricky one too.
Let me grab that one. Oh yeah, I definitely want to talk about the one with the kittens.
So Matt, while you're looking at that, it appears to me that we have to be really careful as we analyze the sentences that's being presented with these questions, correct?
Oh yeah, real careful.
Yeah, to determine what they're really asking for.
And that's, as I mentioned a bit, I think it was yesterday or the day before, that a lot of the stuff we're going to work on in here, the mechanics aren't going to be too bad. The actual raw like math that we're doing is not going to be too bad. A lot of it's going to be vocabulary and context. So it is exactly that kind of thing, making sure we're reading very carefully, particularly later on when we start having more and more tools, being really sure, okay, what tool are we supposed to use here? Which of the things that tool does do we need to apply? It can often be in very subtle wording. So yeah, being extremely careful in how we read the problems and how we answer the problems is going to get increasingly important. So that's one of the reasons that, or one of the reasons why now is an important time to start with that kind of being careful, being real specific about what you're doing. Because right now it might, you could argue, be picky, but later on it's going to be vital that we think that way and that we look that way. So Jesse, absolutely, you got to be really, really careful. So let's look at this one. This one we're given essentially a frequency table in bins. This frequency table we could turn into a histogram if we wanted to. If we were like, I like histograms, I don't like these. Okay, make it into a histogram. You know, the 15, 19, 23, 27, 31, and 35. We could turn that into a histogram. You'd have a couple of 9s, a 3, a 5, another 9, and a 10. You know, pretty terrible histogram, but for throwing it out real fast. This should not have only one number on my histogram, but that's okay. You know, this table and that histogram are essentially trying to tell us the same thing. Fair? So if you prefer looking at a histogram, you can make one. If you have a histogram and you prefer looking at a frequency table, you can turn it back. So based on this distribution above, find the relative frequency for the class with the lower limit of 27. So that's this class has the lower limit of 27. That gray is not. Do that. That's the class with the lower limit of 27. We're given its frequency of 5. We want its relative frequency. Its relative frequency is its frequency divided by the total. We'll often use n for that number of values. So we're not told that in this problem directly. What do we have to do to figure out the total number of students that are in this survey or in this distribution?
Add them all together.
Yep, add them all together. If we total those frequencies, we'll get the total number of people in the survey or in the whatever they're gathering this data from, in the sample if we want. So 27, 37, 45 looks like. That's not right, let me know. So this becomes 5 out of the total of 45, which is 1/9, which if we wanted to write it as a decimal, 0.1 repeating. Give your answers as a percent rounded to one place after the decimal point. So it's going to be ones repeating. So as a percent would be 11.1%. Now we could find the relative frequency for all of them. We could turn this into just a good plain old relative frequency table. If we wanted to do it for each class. And that doesn't sound like a terrible thing for us to do. That would be 11.1%. But we could do it for all of them. The first class with the lower limit of 15 would be 9/45. 9/45 is what, 20%? I'm putting it as a decimal instead of want it as a percentage. So that would be 20%. So that would be 20% as well. 3/45 is what, 1/15? I don't know what 1/15 is as a percent off the top of my head. I'm just gonna write 1/15. That would also be 20%. That would be 10/45. 10/45. Well, we could certainly reduce that to 5/9. 5/9 is 0.5 repeating. So what, 55.5%? That doesn't sound right. That's not right. How about 2/9, Matt? Sorry. Reduce my own fractions, why don't I? So that would be 0.2 repeating. That's more reasonable. Should be twice that 11.1 anyway. 22.2%. How did I know that 55% wasn't reasonable?
Because they all have to add up to 100%.
Yeah, these all have to add up to 100%, right? That 55 was way too big, right? 55 plus 20 plus 20 plus 20, way too big. We could figure out what the 1/15 is as a decimal, either using our calculator, or heck, these all do have to add up, right? So we could take the 100, subtract all the decimals we know, figure out that decimal. Or we could divide 20 by 3 and get, what, 7.3%?
No, it's 6.7% for 1/15.
Oh, other way, subtract, don't add, right?
Yeah.
That's what calculators are for, right?
Yeah.
I don't even expect myself to know that off the top of my head, apparently. So what'd you say it was, 6.7?
6.7, yeah.
But this question did only ask us for that one class limit, just to make it kind of a separate, isolated question. But we could have done it for any of them. Michelle, does that work?
Yes, that makes sense.
Cool.
I think I was just entering it in, different format on the homework.
And that gets back to what Cassie was saying. The answer as a percent rounded to one decimal place after the decimal, or one place after the decimal point, can take a little while to learn to read. It's like, what exactly does that say it wants? So as soon as it's a percent, it turned into 11.1s forever, and then it wanted one decimal, one place after the decimal. So that 11.1, and I think I don't have it.
The decimal.
That's all it takes, right?
Yeah, thank you.
And one of the things that makes the things like the MyOpenMath frustrating is also in some ways one of its strengths. It is very picky. If it says it wants it in a particular way, it better be in that particular way. And that can sometimes be unnecessarily frustrating. But at the same time, it does help us practice that precision. It helps us practice that, carefully reading the problem and reading what the ask is, because if we don't, it's going to yell at us every time we try to say anything. So it can be frustrating, but it's also helpful to kind of be forced to practice that precision. Fair? All right, I want to look at something that came up in a couple of questions that is, not only is it a common question, but it's one that can be pretty important for some of the things we're going to do later. And I'm going to use this taco one as an example. You could use the kitten one or really almost any of them. But there's a set of language that gets used a lot, not only for these histograms, but for the sections we do on probability as well. So some language we want to be careful with. And that is our language of at least and at most. We hear at least or at most fairly often in our kind of day-to-day workings, but it can be surprising when it translates into some of these questions how we can overthink at most and at least and get ourselves really turned around in them. So let's say we want to know how many, use this people, the restaurant record how many tacos were included in each order. So how many orders had at least, let's say, 5 tacos? So take a moment and decide how you would want to answer or approach that question of how many orders had at least 5 tacos, given that histogram. I'll give you a minute to try to decide what you end up with. So how many orders had at least 5 tacos? So what does it mean to have at least 5 tacos? How many tacos could you have if you had to have at least 5 tacos?
At least 5, which means more than.
Which
is what we're
means
looking at.
5, or it could be 6, or it
Or
could
it could
be
be
7,
6.
or it could be anything bigger than that, right?
Right.
When we talk about this at least and at most language, it gives us essentially either a lower bound or at most gives us an upper bound. So when often people see that least and they want to think less than.
Oh, yeah.
Yeah.
And that's very natural, but at least and less than are, mean actually not only quite different things, but they almost mean the opposite things. At least says this is my lower bound, where at most would say this is our upper bound. So at least 5 tacos is 5 or more. That means if we want to put that in our math notation, that means our number of tacos would be greater than or equal to 5. So in our histogram, where is our number of tacos more than 5? Well, this 5 here, is that 5 there a number of tacos?
No, it's a frequency.
That's the frequency, that's the number of orders, right?
Right. Mhm.
Our 5 tacos is down there. So this is telling us how many times 5 tacos were ordered. And that was what, 12 times?
Mhm.
So the 5 tacos happened 12 times, so the frequency.
Got it wrong.
But we want at least 5, so that would be 5 or 6 tacos, which happened, what, 6 times? Or 7 plus, which also happened 6 times. So if we add up those frequencies, yeah, we get Kim's 24. Sure.
Okay.
Now, just your 50, my guess would be you went down, right?
Yes.
And that's probably the most common answer I get to this question is that 50. And it's that association with least wants to be less than, so you go downward. But that least tells us where our boundary is. And it's a fairly subtle change. If you said how many orders have less than or equal to 5 tacos, then 50 would have been right.
Okay.
So it is what you were talking about before, that subtlety in the language.
Yeah.
Let's change this to say how many orders had at most, let's go at most 3 tacos. Take a minute, decide what you want for that. So at most 3 tacos is, say, one of the orders in here, is that at most 3 tacos? Well, that's 4 tacos, right? If we can have at most 3 tacos, we can't have 4, right? I don't know why somebody's controlling how many tacos we have, but at most 3 tacos means we can have 3 tacos or 2 tacos or 1 taco or technically no tacos. So that would be sad. So 3 tacos, how many times did that happen? 3 tacos happened 10 times. 2 tacos happened 9 times. 1 taco happened 5 times. And there were no orders with no tacos because apparently they only sell tacos. Or maybe their tacos are delicious, I have no idea. So if we add those together, we get Actually, we get the same answer, don't we? We get 24. Now, is it 24 tacos? I'm seeing some pretty emphatic no's out there. 24 what's? If we were asked how many orders had at most 3 tacos, our answer really shouldn't just be 24. Our answer should be 24 orders. Most 3 tacos. Fair? Now I'm going to be mean here because that's my job, right? You don't become a math teacher to be nice to everybody. If we change this to how many orders had more than, yeah, I'm going to say more than 3 tacos. Decide what you do for that. Oh, I love when you guys argue. Oh, you're not arguing. You're typing. So more than 3 tacos. Do we include the 3? Do we include that one? Some big, powerful, emphatic head shakes. Good. We more than 3 means we need to be something more than 3. So the 4, the 5, the 6, the 7 plus. So we'd have what, 14 plus 12 plus 6 plus 6 is 24 plus 14. Yeah, it's our 38, which you guys are all spouting off very nicely. And again, 38 what's? You guys were good with that on the thing. So maybe Kristen even said orders on the thing. Very nice. 38 orders had more than 3. So if we wanted to say not say more than or less than, the at least at most, this more than 3, what would that turn into if we wanted to use the at least or at most? More than 3 would turn into, oops, I didn't want that.
At least 4.
That was weird. Yeah, at least 4 would put that into our at least at most language. Now, one of the big reasons I want to stress this is in chapter 6, I think it is, when we start working a lot in probability and some of the binomial distributions, we're doing something a little bit more complicated than counting up how much is bigger or less than. As we start working with a little bit of probability, and that at least and at most language is super common there, and it's really easy to get turned around with it. So being careful and very clear with it now, I think will be hopefully be helpful when we get to that section. And yeah, it is chapter 6. All right, questions about that? All right. Let's see. Is there anything else that you guys wanted to ask about that you've been working on? I really do like that a lot of you have kind of dived in and started working on some of these. That's really, really helpful. Mostly, if nothing else, because you can come in and bring in good, solid questions. And that helps us all. Okay. So since we're talking about histograms, let's say we had a histogram, and I'm just gonna not even have a label on this histogram. So histogram, so this would be frequency, and we could put a scale on here, why not? 20, 10. And let's say, along the bottom here, this is, say, I don't know, feet, why not? And we go all the way from 0 feet, 5, 10, 15, 20, 25, 30, 35, 40, 45, and that maximum there, 50. And let's say this is height of a certain type of tree, height of a certain type of tree, or tree in some particular forest, doesn't matter. This type of histogram is fairly particular. Notice that it's got the kind of classic shape where most of the data, most of the heights fall in or near the middle, with less and less trees occurring at the extreme heights. Less and less trees that are tiny, less and less trees that are really, really tall, with most of them being nice and in the middle. Fair? Histograms that have this kind of classic shape, there's a couple different terms we use for it. We'd often say it's symmetrical, because if we kind of draw a line through the middle, this side looks fairly much like that side. Doesn't have to be perfectly symmetrical for it to have some good symmetry to it. So we might say this distribution looks symmetrical. Instead of symmetrical, sometimes we will hear it referred to as bell-shaped. Mostly because if you look at it, kind of an old-fashioned bell, kind of like a, Liberty Bell or whatnot, and the thing it's hung by, right? So this part of the bell kind of has that low on the outside, kind of shape to it. So often we'll have distributions that kind of have this classic shape referred to as bell-shaped. Also, sometimes we'll just hear it referred to as normal. This data is normally distributed. It's got, most of it in the middle, a little bit, less and less as we go out, and fairly symmetrically so. So this is about the same general shape as that is. Symmetric, bell-shaped, fairly normal. Fair? But there are other shapes. For example, if we had, say, we saw an example earlier of numbers of kids, 1, 2, 3, 4. Let's say the number of people that had 1 kid was 5, the number of people that had 2 kids, 3 kids, and 4 kids. let's say they were all 5 in our survey. Well, that doesn't have any kind of curving to it, right? All of our class values have about the same frequency. Now, there could be maybe one that's 6, you know, but there's not a lot of variation in it. This histogram is fairly flat. Sure. That says our data doesn't have a lot of variation to it. It's not moving around a lot. We often refer to it as uniform. Fairly consistent across. Again, they don't have to all be equal for us to say it has a fairly uniform shape. For it to be a true uniform distribution, they should all be the same. But if it was, you know, one was a little bit above, one was a little bit below, but not a lot of movement in it, saying, oh, that's fairly uniform would be a common thing to say. Fair? So flat histograms, we tend to refer to as uniform. Those are the 2 nice ones in a lot of ways. We won't deal with uniform distributions all that often, mostly because they're boring. You got all this stuff, it's all the same value, just there's not much to analyze. We will deal with bell-shaped curves a lot because the bell-shaped curve, one of the reasons it's called normal is it happens fairly often. It's a very common shape for distribution to have. Also, there's a lot of good analysis we can do. There's a lot of our tools that work nicely on bell-shaped curves. And we'll find later that even data that's not given to us in a bell-shaped distribution, some of the things we're going to do to mess with it turn it into a bell-shaped distribution. So this normal distribution shape is going to be really common for us. But there are a couple of others, with my cursor thing up there, that we want to be familiar with before we go too much further. Let's go back to, say, a different set of trees. So it's still, you know, tree height in feet. And let's say we go to this particular forest, and this particular forest has, you know, a fair amount of small trees. Because, you know, there are baby trees, right? But then we start getting a lot of the bigger trees because, you know, it's an old forest, so it's got a lot of these big trees in it. And then, you know, it tapers off a bit. There are not too many of those giant trees. And I'm going to still put this out to 50 and down to 0. And frequency. Let's say relative frequency, so I don't have to put much of a scale on it. Well, let's say that's 8%. But anyway, this distribution has a lot of data up here on the high end, and then falls off this way. We wouldn't consider it symmetric, because if we tried to kind of divide it in the middle, this side doesn't look like that side, right? If we tried to divide it down the middle at that peak, well, this side is much shorter than that side. The symmetry's not there, right? This type of distribution would be referred to as skewed, because it's tilted, if you want, skewed toward one side. The difficult thing can be, which direction are we going to say that this is screwed? Stephanie, you said that a skewed, I love that, that a skewed left distribution. Why left as opposed to right?
Because the information is obviously less on the left than on the right.
It's less on the left than on the right? Yes. There's less data over here on the left side than there is on the right side. Why would that make it skewed left instead of calling it skewed right? If all the data is, if you, as you said, more of the data is off to that right. Now, the nice thing, Stephanie, is you're correct. But it does sometimes seem counterintuitive. Fair? If we look at what our normal curve looks like, our normal curve, if we round it off, has that kind of general shape. This one essentially had this tail. They are technically called tails. That tail has been pulled out that way, right? That data has been pulled out towards the left. When we talk about skew, that skew follows where it's been pulled out toward, not where that hump has moved. Fair? So we don't want to think about, this, middle part or that middle of the distribution being moved this way. The middle of the distribution is where the middle of the distribution is. Our data has been pulled outward, like stretched out, almost like taffy, towards that left. Fair? Essentially, skew follows the tail. Fair? So this, our middle of our data, most of our data is here. We do have data that's pulled off this way. So we are skewed here. You are absolutely right, skewed towards the left. Now, your text and your homework introduces this idea of skew as it introduces histograms, which it really should. That's a perfectly good thing for it to do. But I'm going to preview a little bit. One of the next things that we're going to talk about after we do our lab tomorrow is our measures of center, things like our averages, our different types of average. And what's the reason we use this language skewed towards the left is if we tried to find an average, our average kind of wants to be where this middle, most of the stuff is happening. Fair? But having all these small values here, that's going to take our average, particularly our mean average, and pull it down towards those small values. It's going to skew our mean average towards the left. Fair? So when we say skew follows that tail, the reason skew follows the tail is because it follows our value average that's getting pulled away. So for some of us, that can help as we try to remember when we're looking at skew, what are we looking at? Because it is really common and really easy to look at a graph like that and go, well, this data is pulled towards that right side, or sorry, towards that left side, the big hump of data on the left. But what direction is the skew here? This is skewed where this tail is going. Again, because really what we're talking about when we're talking about skew is our mean average is being pulled that way. So it is skewed towards that right in this case. So got to be a little careful with that. That can sometimes seem a little, counterintuitive. You should think the bump is on the right, so it should be skewed right. The bump is on the left, so it should be skewed left. Skew follows where the taffy is pulled out, where that tail is extended. That seem reasonable? All right. Again, that's one of those things that's going to come up more and more later on that it's good for us to be happy with. We talked a little bit about dot plots yesterday, or didn't really talk about dot plots yesterday. I mostly talked about the fact that I'm not going to talk much about dot plots. Mostly because a dot plot is essentially a histogram or a bar graph made up of all these dots. They've got a really very dramatic dot plot here in one of the homework problems. And here, each of these dots represents 500,000 households. Couldn't we have just gone, put a scale on this? Oh, my pen won't work on that. I didn't copy and paste it over. But we could have put a scale on that said so many millions and made bars instead of dots. And frankly, that's more common in lots of things. But if we look at this kind of like it's a histogram, what would the skew of this be? Would it be skewed towards the left or skewed towards the right?
Right.
I've got somebody saying right. I didn't catch who that was. And a lot of nods. This is, yeah, it's absolutely skewed right. And again, why is that important? Well, if we looked at this and tried to imagine, okay, this is household incomes. If we tried to say what the typical household income is, well, the typical household income looks like it's in this range in the, 40,000-ish range. But if we tried to average this out, all these people out here who are making, 200,000 or more a year, those people, and particularly if you imagine the people making $1 million a year or a couple million a year, those values can easily skew our average to seeming much higher than it is. Fair? And that average is going to look skewed towards those higher incomes. It's going to be skewed, our average is going to be skewed towards that right side, depending on what kind of average we use. And frankly, that's why we have different kinds of average, because some types of average are affected by skew and some types of average are not affected by skew. If we have skewed data like this, we might go, hey, I'm going to use the average that doesn't affect or isn't affected by skew. And we'll talk about that when we get into chapter 3 on our types of average. But this is just a nice example, one of a dot plot, but also of something where skew can matter a lot. Cool. All right. Any questions you guys have? You seem to be doing pretty good. This early stuff, as Jesse, as you're mentioning, is mostly being careful with our vocabulary. Let's see, I knew there was something in 3.2 I wanted to look at. Is the homework not telling you what the answer is once you get it wrong a couple times? It used to do that by default. It's not doing that anymore. I'll figure out why that is and try to fix that. They updated it. Everybody updates things over the summer. They updated it. So I got to figure out how to fix that. But because I kind of do want it to tell you what the answer was once it tells you you're completely wrong. I think that would help. Let's see, 2.3's got some stem and leaf plots. We talked about those yesterday. You guys seem to like those once we talked about those. Oh, we should at least look at one of those. I don't want to, but we should. So this is a different type of chart. It's not, I'd say it's a different type of chart. It's a line graph, but how different is it? If instead of making these dots with our lines, could we have just gone, hey, make this a bar graph instead? And just said, hey, we really don't need a different type of graph. It's really the same type of thing. This is just the same type of information. It's displayed a little differently. And some people, or some, depending on your application, it's nice to see this, particularly if you're talking about change over time. It can be nice to have it appear as kind of this moving line as opposed to these static blocks. So particularly when you're talking about over time, people like these line graphs. But the information is really the same. You know, what is the population in 1870? Well, 1870 is there, so what's the population? Well, it's still, how high would that bar be? That bar would be at 550, so population was 550. Does it give us any scale here? Oh, it's just people. It's a little village. So often these line graphs can look a little bit more serious, particularly, who was it? I'm trying to learn you guys as you guys blip in and out. I think it was Camilla. You're thinking about this in terms of ordered pairs, you know, the 1870, 550 as an ordered pair for that point. Sure, that is the point 1870, 550, particularly for those of you who are used to thinking in terms of the kind of Cartesian coordinate system. But are we being asked for that pair? If we're being asked for the population, we're just being asked for that value for y. Fair? So don't let the data coming in these kind of line graphs throw you off. It really is the same kind of information. Let's see if any of these look horrible. There's not too many of them, but sometimes they freak people out. Grab that one. So why don't you guys read that and try to decide what the answer would be, see if we're comfortable with these types of charts. Some people like them better, some people like them less. But for us, we'll be dealing with mostly histograms and so forth. We won't see a lot of these line graphs or polygon graphs or whatever they want to call them. But it is a common way to display data, so it is good for them to mention them. So try to answer that question. How many measurements taken? I always thought frequency distribution polygon sounded super serious. It is fun if somebody said, what did you do in school today? Oh, we dealt with frequency distribution polygons. You sound super cool, right? So frequency distribution polygon does tell us that this, like everything else we've been working with, that scale is our frequency. And we're asked how many measurements taken in this time frame were less than 40 ppb. Anybody know what ppb stands for? Do we need to know what it stands for to do this question? Yeah. It is parts per billion, though, in case you're curious. The concentration of arsenic in water, there's, 40 parts or 40 amount of arsenic for every billion parts of water. So 40 parts per billion is a really small concentration. But it's arsenic, so small concentrations can hurt you. So in case you were curious what ppb stands for, parts per billion. But you guys were right. We don't need to know that for this question. So less than 40 parts per billion. Well, 40 parts per billion is there. So how many measurements taken from this time frame were less than 40 parts per billion? That's going to be this dot, that dot, that dot, that dot, and that dot. Fair? Now we also could have said at most, right? So how many are in each of those? That first one is 13. There were 13 measurements at what looks like about, 37-ish parts per billion. There are 4 measurements that came in at about between 30 and 35. There were 5 measurements between 25 and 30. There were 3 measurements between 20 and 25. And looks like no measurements between 15 and 20. So if we add all those up, what is that? 9, 12, so 25? Is it 25 or 26? Kim, you said 26. Is it supposed to be 26? Can I not add?
No, I think you're right.
Okay. If not, we're close, right?
Yeah, you're right. 25.
And again, 25 what's?
25 measurement.
Good, measurements. There were 25 measurements. Now, one of the things that the computer isn't real good at is making you answer things in context. Often it just has a, answer and a block for you to put the number in. And boy, that's in a lot of ways pretty bad for you. Or if it doesn't do that, it'll say things like there were and give a block measurements. It'll write the sentence for you and have you just put in that number. Try to be mindful of that. Try to be careful of that, and be used to trying to make sure you're thinking of what your answer stands for, what your answer means as you're going through. Unfortunately, if we were in class, we'd have more stuff that we would do that would push some of those things. But it's real easy in here to get a little bit lax about context and how you're writing things out. One of the big recommendations I think that you mentioned yesterday, Kim, was if you print these out and then go through and answer all of them, it's much more natural if you're writing some things down by hand to write out those sentences and write these, use your units and be a little bit more formal with it. And I really kind of do recommend you guys do that. Oftentimes when you're working in this kind of computerized format, you'll have a calculator and you won't write much stuff down, and that it's really good for you from a learning perspective to be using your body, using your arms, writing things down, seeing them written down, thinking through how you're verbalizing it, talking to each other about it. You guys were talking about forming a study group, using that language, using your writing, all of that helps build memory and context. So it's really easy to lose a lot of that as you're working on the computer and not writing things down and not getting used to expressing these things. So being mindful of that and trying to make sure your best practices compensate for that is really helpful. So this was more or less my plan today. We went through chapter 1 and chapter 2 fairly quickly on Monday and Tuesday. And I kind of wanted to do that. And then so we could have a day where we're kind of going through questions, clarifying stuff. Tomorrow we will work on our lab and go through some tools for Excel. When we do the labs in general, what I'll do is, we'll all show up here at our same time, preferably. And I'll show you next time, especially because it'll be our first lab, I'll show you where the lab stuff is and show you, how to watch the videos and get the lab stuff out. And kind of just let you guys work on those labs, and I'll be here to answer questions when you get stuck on them, or if you have other homework questions that have come up. So our lab time is mostly going to be you guys kind of working independently, and I'll be here to answer stuff. If you want to look over some of those labs before we work on them, so you can be all ready with questions, then that's great too. If you go to, let me actually bring that up since we've got a little bit of time. You guys had good questions today. Really appreciate that. It does make these days go better. And that's one of the big reasons, as I was talking about yesterday or the day before, one of the big reasons to be working on that homework ahead of time is so we can have those good questions and get as much out of that as possible. So if we open up this week 1 list, you've got your homework sections, a little video on plotting histograms in your calculator. You can make your calculator draw nice little histograms if you want. But how to do the lab is in these nice videos that Svetlana put together. So this lab has 3 little tabs on the bottom of it. So there are 3 little parts to it. And you can go through and watch those videos ahead of time, particularly if you're concerned about using Excel, or you can wait until Thursday. You might watch them and get the whole thing done and not have any questions. And if the homework's all up to date, you might not even need to come by on Thursday. And that's fine. Thursday is just here for us to work on those together, get things answered, and get some help. Fair? The labs are listed due on Monday. So, we'll do it Thursday. Most of you will probably get done Thursday, but it's got a couple day lead until you actually have to turn it in, just so, in case something happens or you need help with something or whatever. But you can turn it in earlier than that if you want. And we'll talk tomorrow a little bit about how to turn them in and whatnot. There's a little bit of a process for that. So we'll talk about some of that tomorrow as well. One of the things that you will need for that lab tomorrow, and so kind of the last, oops, I did not mean to get rid of that. There we go. So it's almost a bit of homework between now and then, is you will need 3 data lists for tomorrow. You need a set of categorical data, a set of discrete data. Well, these days I'm gonna learn how to spell discrete. Like that, isn't it?
Yep.
And continuous. So you'll need some sort of categorical data. It could be, eye color. It could be where are people from. It could be are people, left-handed or right-handed. It could be, just some sort of categorical data. Some set of discrete data and some set of continuous data. If you need to, look in your text and review the difference between categorical, discrete, and continuous, particularly discrete and continuous, do so. How much data? The general rule of thumb for our data is going to be at least 30, I want to say values, but categorical won't be values, at least 30 data or data points or 30 responses, however you want to put that, at least 30 for each. So if you're doing like color of an M&M, you want to have 30 or more M&Ms that you're finding the color of. If you're doing the weight of, why not M&Ms, if you have a lot of M&Ms around. If you're weighing them, make sure you weigh at least 30. Some of our tools later, for our tools to be valid, require us to have at least 30 data points for our tools to work. So kind of getting in the habit of having at least 30 data points is a helpful kind of practice to get into. So you'll need these for not only the first lab, but as we go along, the labs will often ask you to grab your set of data. And you'll be able to use either these data that you grab for this lab, or you can use new data if you want. But it's nice as we go through the course for you to kind of collect data about some things that you find interesting or compelling. So for example, if you're a painter, you could have data on your different colors of paint, or data on the different prices of paint for something more discrete, or data on the viscosity of your different paints, if your paint viscosity is important to you. So gathering some of this data based on something that you find compelling and interesting will make the labs and the things that we do with this data more compelling and more meaningful to you as we go along. That all seem reasonable? Okay. Anything else I can do for you today before we head out? I mean, I could start talking about chapter 3, but I don't want to pile too much on top of you. We got to go a little quick over the summer, but I got to not get ahead of myself too much. And my tendency for this summer is going to be like this. I'll throw a lot of information at you in the beginning of the week, and then we'll kind of spend some time answering questions to make sure we're happy before we move on. So if in the beginning of the week you're looking at the homework, which you should be doing in the beginning of the weeks, and it's a lot, and you're starting to generate a lot of questions, not very sure about it, that's often where you should be, and that's okay. Bring in those questions, we'll clarify stuff, and hopefully be happy by the time we're done. But that process really works best if you guys are working ahead, or working, in the beginning of the week as we go along. Again, as I said before, if you put stuff off, things are gonna be in trouble. Okay. Okay, yes, I certainly have time. I know there are some registration things going on, lots of them. I think I've gotten 3 emails and messages from you guys. The big thing right now is, as long as you are in my roll book, which means you're on my open math, you're safe and we can fix almost anything. Fair? Exactly what needs to happen to fix that, I can't do anything about it until the instructor portals open up. So really right now, I can't get into any registration information other than Blackboard. And even the stuff on Blackboard, I can't add or take away people from Blackboard. So it's supposed to be the middle of this week where those instructor portals open up, and we can start, getting some of those things fixed. But for right now, I would just try to not worry about where your registration status is according to what the school is saying. As long as you're in the My Open Math, you're good, you're safe, everything will be cool. The emails that I'm getting from the administration are mostly essentially that. Try to reassure your students that as long as they're in class and doing stuff, we'll fix, and we can fix anything. And try to not have them get too worried about it because, they can't fix it right now, or, they're in the process of trying to fix everything. But until they get those things fixed, they can't necessarily fix what your particular registration status looks like. Does that make sense? We actually have the benefit, the math classes have the benefit of having the My Open Math. So we have a list of who's active students. So we are safer than a lot of classes. A lot of classes, if you've got, they're on Zoom, and whether you can get into Zoom or not is often a question. So it can be really complicated for some of the other courses. For us, with the My Open Math, we have, if you're on My Open Math, you are 100% safe. So that's my spiel about registration. If you have anything more specific, I'm happy to see if there's anything I can tell you. But I don't know what's going on either. But yeah, if you have anything more specific, let me know. If not, that's what I've got today. And if you have any other questions, you can send them to me. If you want to hang around a bit and ask any questions about registration or anything else, great. If not, have a wonderful day. And let me know if anything you guys need. Bye. For the change.
I had a question.
Shoot.
So we're doing class every single day except for Friday, right?
Right. The
Okay.
Thursdays are lab time essentially, so I won't be doing too much lecturing on no problem on Thursdays. At least for a while, as we get into as our labs get more spread out, we start getting into some of the more elaborate material. We might have more lecture-like discussions on Thursday. But we are going to meet Monday through Thursday. For a fair amount of folks, their schedules won't line up with that, and that's okay. I am recording these sessions and posting them on My Open Math. So you'll be able to, if you have to miss one for whatever reason, you'll be able to watch it, if that's helpful.
Yesterday there was a student that was saying that he was having a hard time purchasing the book. I have a PDF version if you're okay with me sharing that.
I wouldn't tell me that you're doing that, because the math department wouldn't encourage that in any way, shape, or form.
Okay.
If you want to talk about that more, I could turn off the recording.
I just didn't know if that was something that was okay to do or
not. No.
I also didn't know who the student was.
Why is that not okay when we can rent a book or you can borrow a book?
Publisher, copyright,
I mean, I did buy it, so it's...
Yeah, but at some place when you bought it, there was something that said for personal use, not to be disseminated or whatnot. There would have been something that said that. But I think it was, I'm Jesse.
Okay.
Who had said that. I'm certainly not going to even recommend you send me a copy of it. I wouldn't recommend that at all. That would be wrong.
All right, noted. Don't send anyone any copies.
Right. Anything else I can cryptically answer?
I just wanted to double check on that. So I just sent you the little message about the registration thing. I just got an email from them saying to contact my instructor and you have to notify the office by Thursday. Is that fall under the don't worry about it, I'm in the open math? Because originally I registered for this and it was like a lecture and a lab combined, and then
Right.
it split. So just want to make sure I'm good to go for,
Yes.
okay, perfect.
Make sure you're here tomorrow. Tomorrow,
Yeah, I will.
I've got to send in all the stuff that says who's here and who's not.
Okay, okay, perfect.
And everyone who's on My Open Math gets sent the they're here.
Okay, thank you so much.
Yeah. And the wait list, this class doesn't have a wait list. We're not even full.
Okay.
So
Yeah, I don't know what they were.
But
I
they're
got like 2 emails very similar of that. And I was like,
yeah.
okay.
But yeah, as of Thursday, that should all, they said end of this week, it should all be clear. But my big job on Thursday is to send in and tell them who's here and who's not. And that's My
Okay.
Labs Plus. Oh, sorry,
Awesome.
My Open Math.
Thank you so much.
No problem.
See you tomorrow.
Yep. Anything from anybody else? You guys good? Then why are you still here?
Because I want to ask you the difference again between discrete and continuous.
Okay.
Discrete in between.
Discrete essentially means separate.
Right.
So
Okay.
if data is discrete, that means there is separation, not necessarily between the values of your data, but separation between the possibilities
Okay.
of the values of your data. So, for example, if you were looking at model year of cars,
Right.
you might have cars that are, 2016, 2018, 2017, and those fall under very discrete categories of values. There's separation between those numbers. You're not going to have a 2016 and a half model year.
Right.
There might be exceptions to that. I have no idea. I don't know anything about cars. Now, that doesn't necessarily mean you have all of those, but your data exists in those discrete chunks.
Okay.
For continuous data, your data is allowed to be over a continuum. So if you're talking about mass of cars, like how much does the car weigh, you might have one car that weighs, say, 2,500 pounds, and another car that weighs 200 or 2,700 pounds. Those weights are separated, but they don't have to be. There could be a value in between any two weights of cars.
Okay.
Kind of the rule of thumb, to be continuous, given any two values for your data, is there always the possibility of being something in between?
In between.
If there is always the possibility of there being something in between, it's continuous. If there are breaks in between, if you get down to some smallest unit where there's a break in between, it's discrete. Fair?
Yes. Thank you.
Sure. No problem.
Thank you for answering my questions too from before. So.
Oh gosh, again, I love questions. Questions really help drive this a lot. So it tends to be those usually a handful of people who lead a lot of those question work, and they're usually fairly happy by the time we're done because they get it's almost focused around what they need. And a lot of other people go like, oh, I'll just let Camilla ask questions.
Well, yeah, I want to figure out what's going on here.
No, that's good. It's very helpful all across the board.
Okay, thank you very much, and I will
No
see.
problem. Okay. What about you? Anything you need, or are you just hanging around? I can't tell if you're. Well, I'm going to head out. If there is anything you need, let me know, and I'll see you tomorrow.